single phase bridge type cycloconverter with the R load. This is the circuit which consists of converter 1 and 2 are full wave converters connected back to back to the R load. To get the positive response, converter 1 is operated. To get negative response, converter 2 is operated. I am considering a 50 Hz AC supply and I want to step down that frequency from 50 Hz to 10 Hz. This is our input voltage waveform. For 50 Hz, it's taking up to 2 pi radian. Converting to time, it is near about 20 milliseconds. Now, I need to step down that to 10 pi 100 milliseconds. Up to 5 pi, it's a positive wave we need to get, and 5 to 10 pi, we need to get negative wave, which means from 0 to pi, I need to operate the converter 1. 5 pi to 10 pi, I need to operate converter 2. And it is fed with the same supply voltage. In positive half cycle of the source, P1, P2, N1, N2, since both are in forward biased. In negative half cycle of the supply, I can operate P3, P4, N3, N4, since both are in forward biased. And regarding alpha, is the firing angle. If it is 0, so 0 milliseconds, 30 degrees, near about 1.16 milliseconds. For 60 degrees of alpha, it's 3.33 milliseconds. For 90 degrees, it's 5 milliseconds. In positive half cycle at alpha, I'm turning on P1 and P2 since both are in forward bias. Converter 1, this voltage appears across the load R. Then the path will be in positive half cycle from 0 to pi to P1 to R load to P2 to Y. At pi, the voltage is reversed. Then P1, P2 comes to natural commutation and stops conducting. Then at pi plus alpha, negative half cycle between pi and 2 pi, I'm turning on P3 and P4. Then the current flows Y2, P3 to the R load to P4 to X. But the direction through the load is positive. The positive voltage appears across the load. This is due to P1, P2. This is due to P3, P4. This cycle repeats until 5 pi. P1, P2, P3, P4, P1, P2. After 5 pi, I need to operate the converter 2 so that I can get 1 Hz step down frequency. Now, this is a positive cycle. Now that I need to get negative cycle. At 5 pi, it's a negative input voltage. Then in negative input voltage, regarding converter 2, I can operate N3 and N4. So I'm turning on N3 and N4. So negative. Between 5 pi and 6 pi, the current flows Y2, N3 to the load to N4 to X. Here the current direction is reversing when I use the converter 2. The voltage appears. This is due to N3, N4. Next, this is a positive input voltage. So in positive input voltage, converter 2, N1, N2 belongs to converter 2. So I'm turning on N1 and N2. So in positive 6 pi to 7 pi, the current direction is X to N1 to the load, N2 to Y. Current flows in reverse direction. Output appears in negative half cycle. This is due to N1, N2. The cycle repeats until 10 pi. N3, N4, N1, N2, N3, N4. Now, the resultant waveform for this is our resultant, which is taking near about 10 pi radians to complete one cycle, which is nothing but 10 Hz frequency.